Stop learning API tools. At least, not the way most people learn them. Which API tool should you learn in 2026? A traditional API client? Something inside your IDE? Or should you let an AI agent handle it? Well, it's wrong question. The better question is what knowledge will survive when the tool changes? Because interfaces are temporary. Patterns move, syntax changes, workflows evolve, but every API tool still works with the same foundations: requests, authentication, data, and verification. The interface is temporary, the knowledge underneath it transfers. I learned this lesson from experience. I learned where to manage environments, where to add authentication, and where to write test scripts. I became fast inside that interface. But speed inside one tool is not the same as understanding the system. Then I joined another team, and the interface was completely different. The tools changed, automation changed, even the workflow changed. But it was the same system. It still received a request, identified who sent it, processed the data, and produced an outcome. The software changed. The engineering problem didn't. So, how do you learn a tool without becoming dependent on it? Use four steps: translate, trace, verify, transfer. Let's start with translate. Translate each feature into the engineering concept behind it. An authorization tab is really about identity and access. Environment variables are about configuration and scope. And a test script is verification logic expressed in that tool. Don't only ask where the feature is, ask what engineering action it performs. Second, trace the complete interaction. Take the send button. Its real job is to execute a request and begin an interaction with the system. Start with the what was sent, the method, URL, headers, and body. Then inspect what was returned, the status, headers, and response body. Finally, ask what changed in the system. Was data created? Was its state updated? Did the expected behavior actually happen? That gives you a tree level of evidence. Third, verify the outcome, not only the response. Imagine updating an email address from the old value to a new one. The API returns 200 OK. But when you check the stored data, it still contains the old address. The request was accepted. The response looked successful, but the expected change never happened. This is why a status code is evidence, not the final verdict. Finally, test whether your knowledge can transfer. Rebuild one familiar test in a different environment. Move it from an API client into code, the command line, or another tool. Keep the same intent, the same request, and the same verification. You are not trying to master more software. You are checking whether your understanding survives when the interface changes. If the implementation changes, but the logic survives, the skill is yours. And this is where AI becomes extremely useful. AI can generate a request, convert a test into code, explain unfamiliar syntax, and propose edge cases, often in seconds. That makes implementation faster. But generating a test and knowing whether it is a good test are different skills. AI does not automatically know which business rule matters most, which failure creates the greatest risk, or what evidence makes the result trustworthy. It can propose. The engineer must evaluate. Use AI to accelerate the implementation, but keep ownership of the judgment. So, learning any API tool becomes a repeatable process. Translate the features into engineering concepts. Trace the request, the response, and the outcome. Verify that the expected change actually happened. Then transfer the same test into a different environment and use AI wherever it helps, as long as you can explain and defend every important decision. That is how you learn the tool, without trapping your knowledge inside it. Well, which API tool should you learn in 2026? A traditional API client, something inside your IDE, or an AI agent? The honest answer is whichever one fits the work. Choose based on the task, your team, and your environment. But don't confuse choosing an interface with developing an engineering skill. The tool depends on the context. Your understanding shouldn't. AI will make implementation increasingly automatic. That doesn't make engineers irrelevant. It changes where their value comes from. Requests still need clear intent, systems still produce real outcomes, and someone must still decide whether those outcomes are correct. So don't compete with AI at producing syntax faster. Become the engineer who understands the system, recognizes the risk, and knows which evidence to trust. Learn the principles, develop the judgment, then use every available tool, including AI, to move faster. Tools will keep changing. Your understanding should keep transferring. And welcome to Request Response.